All right, so yesterday we started exponential functions. Okay, we saw that when you sketch those graphs, they curve up very, very quickly. Okay, when we sketched the graphs, okay, we had a number in front. Okay, like 5, 3. Okay, in the warm-up, we had some other examples. 4, -4. What do you notice every time about the number that was in front? Okay. Look at these examples. 3, 2, 4. All those numbers are bigger than what?
1.
They're all bigger than 1. Okay, they were always bigger than 1. What do you notice about the number in front here, 1/3? It's bigger than 1?
It's a positive.
Yeah, but how about compared to 1?
Bigger than 1. Smaller than 1.
Smaller. Okay, so when we had a number bigger than 1, what did a bigger number cause to happen? The graph what? It took the graph and it stretched it. Okay. Well, when you put a number smaller than 1, let's see what happens. Okay, we're going to get kind of the opposite. Okay, you know what? I think you guys already have the graphs on your sheet.
Yeah.
Okay. Let me show you. I think on the calculator it'll be easier. Okay, here's, I'll do 2 to the x in blue, and then I'm going to do 1/3 2 to the x. Okay, that's how I have to type in 1/3. Okay, 1/3 is going to be in red. Tell me what you think the difference is. It's the original. What happened to the one in red?
Stretch it went further.
It went out. What do you think? Okay, let me show you a vertical stretch. Some people are getting confused from yesterday. Here's a vertical stretch. Okay, the one in pink. Okay, here's what we did yesterday. Why can't I type 2? Okay, the one in pink is a vertical stretch. Okay, it's a vertical stretch because it starts to curve up sooner.
Yeah.
How about the one in red? Curves up later.
It just took longer.
Took longer. So what's the opposite of stretching?
Shrinking.
Shrinking. Okay, so when you put a number in front that's smaller than 1, what happens is, well, you could say it 2 ways. You could say it shrinks, or you could say it stretches by 1/3. If you stretch something by a fraction, it makes it smaller. Okay? It's kind of like if I said, take 10 and multiply it by 1/2. Does it get smaller or bigger?
Bigger.
Half of 10?
Smaller.
Smaller.
Right.
Okay? Anytime you multiply something by a fraction, it will get smaller. Right? So we could say this is being stretched by 1/3. It's only 1/3 as big as it would have been. Okay? Some people say compressed too. I think it's going to get confusing. If you say compressed, I think what we'll do is we'll always say stretched. If you stretch by a fraction, it makes it smaller. Just like if you multiply a number by a fraction, it makes it smaller. Okay? That's the basic idea.
Is it still exponential then?
It's still exponential because it still curves up pretty quick. It's just a little bit slower than it was. Yep. Okay. So here's the same graph I just showed you. Now look at what happens when you do a negative. What did the negative cause this graph to do? It's basically like I just put a negative in front of the one in red. What happened to it?
Cross reflect.
Yeah, it flipped it. Okay, so the negative still does the same thing. Okay, that's going to cause it to flip. But if you put a number smaller than 1, it's going to cause it to stretch by a fraction, which actually makes it smaller. Okay, let's write that down. Okay, so you should have a spot on your note sheet for that. Okay, right at the bottom, right above the box, it says exponential growth. If the number in front is between 0 and 1. Okay, what happens is the graph is compressed instead of stretched. Okay, and there's two ways you can say it. You could say the graph is compressed. Okay, or, I think the second way is going to be easier for most of you to remember. You can still say the graph is stretched, but it's going to be stretched by a fraction. And when you stretch something by a fraction, it makes it smaller. Okay? Just like when you multiply a number by a fraction, it makes it smaller. Okay, if that seems tricky, think of this. 10 divided by 2, 10 times a half. What do both of these come out to? 5. This is two ways of saying the exact same thing. This is two ways of saying the exact same thing. Okay? I'm going to, in class, I'm going to do it the second way. I'm going to say the graph has been stretched by a factor of, and then fill in whatever your fraction is. Okay, just remember, what really happens when you stretch by a fraction? The graph is really made shorter. It's really compressed. Okay? If you stretch it by a number bigger than 1, what happens then? Yeah, it gets longer. That's when it really stretches. Okay? Number bigger than 1 will stretch it. Stretching by a fraction less than 1, it really compresses it. Okay? Okay. If A is negative. Okay, if A is negative, well, just squeeze it in right below what you just wrote. There's no spot for it, but just squeeze it in. If A is negative, this causes the graph to reflect over the x-axis.
Where did you write that?
Just squeeze it in right above exponential growth model. There's no line for it. Okay, this part is exactly the same as what you did yesterday. There's nothing different here.
You put that somewhere?
Yep, just squeeze it in right above the box. Okay, even if you forgot to write it, you still have it from yesterday. Yeah, don't put it in the box. The box is for something else. Put it wherever you can. Okay, does everyone have the second part? If A is negative, this causes the graph to reflect over the x-axis. Okay, technically, if you guys wrote this yesterday, you don't need to write it again. It's the same thing you wrote yesterday. Okay? Right, so same kind of problem we had in the warm-up, same kind of problems you did in the homework. I want to compare this to that. So guys, y equals 1/5 times 2 to the x. Who can tell me what the 1/5 is going to do?
It's gonna.
Remember, you can write it two different ways. Let's write it this way. Copy what's written right there. So who can tell me what the 1/5 is going to do? All right, so we could say it that way. I would say, let's do it the way I circled though.
I can't do that.
Graph is stretched.
Yeah, say it that way. So y equals 1/5 times 2 to the x is a vertical stretch by how much? It's a vertical stretch by how much?
By half. 1/5.
By a factor of, what'd you just say, Eli?
1/5.
1/5. Now, I want you guys to really remember though, when you stretch something by a fifth, what does it really do? When you stretch by 1/5. It's a number less than 1. What did we just say?
Oh, compressed.
Right. Okay, I'm having you guys write it this way so you can write it exactly the way you did yesterday. I think if I have you guys start writing it when using the word compress, people are going to get confused. Okay? So write it just like you did yesterday. It's a vertical stretch by a factor of 1/5. Okay, this example is on your sheet I just passed out. It's example 2 on the sheet I passed out today. Yep. Example 2. Okay, any questions on that? Okay, let's do, I'm going to make up another one. It's not on your sheet. Compare y equals 1/2 times 4 to the x to y equals 4 to the x. Okay, this is one I just made up. Okay, what's going to happen here? Tell me exactly what I'd write on the test. Dominic?
It's going to compress by half.
Stretch.
Vertically stretched.
Yep, so vertical stretch by a factor of how much? By 1/2. Okay, now I want you to remember what really happens when you stretch by a half. The graph really gets what? Compresses. Okay, I'm not going to have you write that because I think it's going to get too confusing. Just write it this way. Vertical stretch by a factor of, and then just stick in the number that's in front of, right after the y equals. Okay, any question on that? Okay, so everyone understands number here less than 1. If you stretch it by that, it really causes it to compress. Number bigger than 1 causes it to stretch. Okay, everyone's all right with those? All right. All right, so all the types of graphs we've been looking at, okay, they're all exponential growth. Okay, in order for a graph, this part, you're just watching me do this part. Okay, in order for something to be exponential growth, notice what I wrote right here. Okay, you've got to have a number bigger than 1 for B. Okay, that's very important. Okay, we haven't talked much about B. We've been doing a lot with A, but not B. Okay. I want you to look at these two graphs. Okay, look at the one in blue. What's A in the one in blue?
0.
1 times 2 to the x.
Oh, 1.
A is 1. Okay, what's B?
2.
B is 2. Okay. Is 2 bigger than 1? Yeah. Okay.
Yes.
So this graph, if I draw it, because I picked a number for B that's bigger than 1, it's exponential growth. Okay, it goes up very quickly. Let's type in a number smaller than 1, okay? Like 0.5. Okay, 0.5. Is that smaller than 1? Is 0.5 smaller than 1?
Yeah.
Okay, what's going to happen here, because we didn't pick something bigger than 1 for B? Look at my graph now. Is it growing?
No.
No, now it's decaying. Okay?
It's opposite.
Yeah, it's the opposite. Okay, we're not going to study the opposite this week. This week, all we're going to do is look at it when it grows. Okay, when B is bigger than 1.
Joey, why are you touching the
Okay.
stall?
When something goes up exponentially, okay, you might have heard this kind of wording before. Has anyone ever heard of something like the city's population went up 2% every year?
Yes.
Something like that? That's exponential growth. Okay? If something goes up the same percent every year, it's growing exponentially. Okay? In other words, it's growing very quickly. Okay? Let's say, here's another example. Okay? You had $100 to start, and that amount of money doubles every year. Okay? Well, after 1 year, it's 200. Okay? And as it keeps doubling, look how quick it goes up. If something doubles, it goes up very, very quickly, right? So in other words, if you had a population that was going up the same percent every year, the number of people could start to go up very, very fast.
So just like
Right.
your
Yep. Same thing with like salary. Sometimes people get like a 2% raise or 1% raise every year. Okay? If that continued forever, that would be exponential. Okay? It can't continue forever because there's not enough money. But, okay, if something goes up the same percent over the same time, that's exponential. Okay, so now in your box on the bottom of that sheet,
Which one? Just
the one with the box that says exponential growth model. Okay, in that box, I want you to write down this equation. If you write down this equation, it's going to make all the word problems very simple.
where? In the box.
Right in the box.
Oh.
Okay, this is the equation that models exponential growth. Yeah. Okay, so here's your equation. Y equals A times 1 plus R to the T. Okay, Y equals A times 1 plus R to the T. Okay, I'm going to show you what each letter here is. Okay, A. Okay, A is the initial amount. Okay, so let's say you're talking about like a population of a city. Maybe it's what the population started at. Right? If you were talking about how much money you had in a bank account, maybe it's how much money you started the account with.
Can you move them grading down to
Okay, R, that's your rate. Okay, what's the percentage that it's going up each year? Okay, is it 2%, 3%?
Wait, is B on the page?
Yeah, B is no, R is just R.
What is
Yeah, but
B
there's
is
no
on?
R.
Yep, I'll show you. I think the letters are wrong on your page. I'll show you. Okay, what does it mean when it says rate as a decimal? Like-
That means the closest decimal.
Like, how do you write 2% as a decimal?
0.002.
Yep. Okay, so you're going to have to do this kind of stuff. We did this way back at the beginning. Okay, and T, that's your time. Okay, in other words, if we said we're going to leave our money in a bank account for 5 years and see how much money we have after 5 years, T would be the time period. All right, so on your worksheet, okay, A is fine. Write down initial amount or how much you're investing.
So is B R this time?
Yep. On the worksheet, change B to R. Okay, R is your growth rate, or if you're talking about like a bank account with money, it's an interest rate. Okay, and T is the time period, usually in years. Okay, for all your problems, it'll be in years. Okay, so to use this formula, you need 3 things. You need A, you need R, and you need T. Okay, does everyone have this formula written down? Okay, now on your other worksheet. Okay, the one that says example 3 at the top. Yep, it's the one I passed out today. Okay, we're going to look at a problem, but keep this other worksheet side by side so you can look at the formula. Okay, keep what you just wrote down right next to it. Okay, guys, I don't need anybody to talk right now. I can handle the talking until I ask a question. Thank you. Okay, we're just going to read through the problem, make sure we know what's where. And we're just going to try to circle what's A, what's R, what's T. You've got to find those 3 things. Okay, first thing it says, okay, in 1953 a car was sold. The owner bought the car in 1984 when the value was 11,000? Okay, so what did the owner pay for the car?
11,000.
11,000. This was the starting value. Okay? That's A. Okay, that's the amount that the value of the car started at. Okay, do we have a rate?
6.9.
Yep. There's our rate. How do we write 6.9 as a decimal? 0.69. There's our rate. Okay, so we're going to fill in. So this is A. This is R. We're just going to fill in those two things. What's T? Well, we don't know. Okay, T, they could say find the value of the car 2 years after they bought it, and T would be 2. Find the value of the car 5 years after they bought it, and T would be 5. Okay, that's going to be my next question. Somebody tell me what's the equation we're going to use. You don't even have to fill anything in yet. Just tell me the equation with all the letters in it. Y equals, yep.
A parentheses 1 plus R parentheses
T. Okay, now just fill in everything you can. If you're missing something, just fill in what you can. Okay. Y, never fill in for Y. Okay, just like we've been doing all week. Never fill in for X if you have it. Never fill in for Y if you have it. Okay. Ryan, what's A here?
A is 11,000.
Yep, good. A is 11,000. This is the initial amount the car was worth. It's the starting value. Now I need my rate. What's my rate in this problem as a decimal?
0.69.
Yep, point. Sorry, I should have written.
It's 0.6.
Yep, I had my decimal in the wrong spot. 0.069. I wrote the numbers right and had the decimal in the wrong spot. Okay, 0.069. What exponent do I need to put?
T.
T. Now T is going to be how many years later do we want to know the value of the car? 5 years later, 10 years later? We can fill in whatever we want. Okay. What do you get if you add 1 plus 0.069? Yeah, just 1.069. Okay, so on a test, I'd like you to add those two things up. Okay, 1 plus 0.069 is 1.069 to the T. Okay, that's all they want for part A. Okay, any questions on this equation?
No.
Initial amount, rate, and all we did was add them up. Okay, now part B. Part B says the car was sold in 2004. What was the value of the car when it was sold? Okay. To figure that out, we've got to plug a number in for T. When did this person buy the car? What year?
1984.
The car was bought in 1984. It was sold in 2004. So how many years later is that? 1984 to 2004.
I don't know, that's like 30.
That's more than 30.
10? Yeah, if you're not sure, you could just subtract. Take 2004 minus 1984. It's a difference of 20 years. Okay, so what I'm going to do is I'm going to write down a little hint at what we're about to plug in.
What does that say?
The car was sold
What kind of car is it?
20 years later. It doesn't say.
Because they were made in 1950.
So, how would you use this formula and the fact we sold the car 20
So
years
plug
later?
that in for T.
Yeah, you're going to plug that in
I think I get this.
for T.
Just
Okay?
sure. I don't.
No, that was 96.
Okay, does anybody have any questions on where the 20 came from?
You subtracted.
Yeah. Okay, they bought the car in 1984. They sold the car in 2004. So they sold the car 20 years later. Okay, so T is 20. Okay, so fill 20 in. Now we're going to need our calculator. Once I type this in, this is going to be the value of the car. So we got 11,000, 1.069. What's my exponent?
20.
Well, T is now what?
20.
20. Okay, filling in 20. Yeah. All right, for this part, you got to use your calculator. Okay, so once you turn it on, type in 1.069 to what power?
20.
20. Do this first. Forget about the 11,000. PEMDAS, exponents first. Right? Raised to the 20th power. Okay, so we get 3.79. Let's round that up to an 8. 3.798. Now, what do I do with these two numbers? Multiply them. Okay, 3.798 times 11,000. Well, you could have typed 11,000 first. It doesn't matter. Just multiply them together. And now the value of the car is $41,778.
Wow.
Right. So you can see that over 20 years, basically the value of the car, it a little more than doubled. It was worth $20,000. Now it's worth $41,000. All right. Now this is assuming that the value of the car went up every single year. That doesn't always happen. Okay, sometimes the value goes up a little bit, then it goes back down, then it goes up again. We're trying to make it as simple as possible. Done?
Is there any way that you can figure out what it was in 1953? Like, could you remember?
In 1953, yeah, we could try to go backwards. Okay, if we did like a negative number for t, like if you plugged in -1, that would be 1983. If you plugged in -2, that'd be 1982. So you could go all the way back and see what it comes out to. And that would have been the price that the car was sold at when it was made. Yeah. So we'd have to go back in time 74, 64, 54, 31 years. 31 years is when this guy bought the car after it was made. Yeah. Again, that's also assuming that the value of the car always increased at exactly the same amount every year. But it might not be true. Yeah, good question. Okay. Any, yep, sign out. Any question on that? Okay, so let's say on the final or on the homework or maybe on the test this week, I said something like, you have a, let's say, you have an autographed picture.
Ooh, by who?
Who do you want?
Jordan.
Michael Jordan. Okay, you have an autographed Michael Jordan picture. Okay, right now it's worth $500. Okay, I just want you guys to watch this one, see if you can figure it out. It's going to be similar. Okay, you got the picture. In, let's say, 2009. Okay?
$500 for a picture?
Yep. Okay, you sold the picture.
I could have bought it yesterday.
Okay, you sold the picture in 2014. Okay, the picture went up, let's say, 7.5% each year. Picture gained 7.5% per year. Find the value when you sold the picture. So basically find the value in 2014. Okay. How would I do this? Anybody see any numbers here that would represent a certain letter in the formula? Dominic?
The 7.5 would be R.
Okay, 7.5%. How do we rewrite it?
0.7 or 0.0.
Good. Okay, so we got our rate. Okay, so we took care of this. Anybody see anything else? What's the 500? Yeah, that's the original amount the picture was worth. Okay, again, this isn't on your sheet. I just made it up right now because I remember what I put on the test, and this is very similar. Okay, what about T? Well, T is how many years have gone by since we bought the picture and when we sold it. When did we buy the picture? 2009. When did we sell the picture? 14. 5 years later. Okay. Who can give me my equation?
Y equals
500.
Yep. Start with your original amount.
And then parentheses.
Yep. 1 plus. You got that?
Power of,
What's my exponent? In this case, it's a 5. Okay. In this case, it's a 5. Okay. What math operation would you do first here?
parentheses.
Follow PEMDAS. Do your parentheses. Good. What do you get when you add 1 to 0.075? 1.075. Okay, I'm not going to keep going through, but what would you do next?
Multiply the 1.075 by itself 5 times.
Yep. Do your exponent,
And then you multiply the 500 by what you get as the outcome.
and then multiply by 500. Then you can find the value of the picture. Okay, does everyone understand how to recognize A, R, and T? Those 3 things. All right, so the next problem, you guys will probably be able to figure out without me even saying much. It's a money in a bank account problem. Okay, how many people understand how interest works in a savings account? Okay, so interest.
Don't you get like a penny a day?
Okay, depends how much money you have, but basically interest is what the bank gives you for giving your money to them to hold, right? Because what happens is when you put your money in a savings account, the bank has that money, and then if somebody comes to get a loan, they want to buy a house, buy a car, that's how the bank has money. They loan your money to other people, right? So then if you need your money, you can go to the bank and get your money, but let's say you had...
They're giving my money away to other people?
Yeah, that's how banks make money. They use your money to loan it to other people.
But they still have their money.
But they can still get it, yeah. That's the thing. Like if you had, millions of dollars in the bank account, you went to the bank that day and said, you know what, I want all my money today.
They give it all to you.
Well, the bank's not going to have it that day. They say, we can have your money, but you got to give us a couple days because we got to get the money. How does
They give it to you.
But they'll give it to you, yep. But if you need that much money, it's going to take the bank a little time to get the money.
Oh my God. Now I know why my dad needs to pay.
All right, so compound interest, okay? Let's say you put $100 in your bank account beginning of the year, January 1st, okay? You check your balance at the end of the month. Let's say you don't put any more money in, you don't take any money out. Maybe you have $101, okay? That $1 is interest. Now you start making interest in February. How much money do you have in your bank account the first day of February? $101. So now you make interest, not just on the $100, but you make interest on the 100 plus the $1 they put in your account for you for free. So maybe at the end of that month, instead of making $1 in interest, you make $1.02. You make a little bit, yeah. And then the next month, you make a little bit more interest. Yep.
Where did they get
So-
do they just have like a stack of pennies? Just like, oh, there you go, put a penny in.
It's all on paper. They don't actually have the, if you need the money, then they get it, but it's all on paper. Yeah. All right, so the idea with this kind of problem is you're going to put a certain amount of money in a bank account, you're going to make a certain interest rate, and you're going to leave your money in the account for a certain number of years. Right, Ben? You already have this information on the sheet. Okay, that sheet you just wrote down, A times 1 plus R to the T. It's the same thing. A is how much money that you have in your bank account. R is the interest rate the bank pays you. T is how many years you leave the money in your bank account. Okay, so let's finish up with this one.
That's it.
Okay, this example is on your sheet. Example 4, right at the bottom. Okay, Travis, can you tell me what's A or R or T? Any one of those?
A,
Yep, how'd you get that?
because that's the amount of money that you put in your savings account.
Right, this is A. A is the amount of money you put in your savings account. Anybody see one of these other two? Yeah?
4%.
Yep, 4%. Just be careful how we write it.
5 years.
How do we write the 4%? 0.04. Okay, Eli, you said something else?
Said 5 years.
5 years. Okay. Those are the 3 numbers we need to fill in. Okay, so let's fill it in and let's see if we leave our money in our bank account for 5 years and the bank pays us 4% interest, how much money will we have at the end of 5 years?
That's huge interest.
Yeah, it's a little bigger than what you'd get today. It's a lot bigger. Okay, who can give me my equation?
250.
Good, 250,
Okay, 250.
parenthesis.
Say what?
Plus 0.04
1 plus my rate, which is 0.04.
times.
And what's my time?
To the fifth.
To the 5th power. Okay, what's 1 plus 0.04?
1.04.
Good, 1.04. Okay, hang with me, guys. We're almost done. We got 2 steps left, and then we're done this problem. And we're done for today. Okay, what's the next thing I do?
You multiply 1.04 by itself 5 times.
Yeah. Take 1.04 and raise it to the 5th power. Okay, right, 1.217. Round that up. Okay, 1.217.
Okay, let's put 1.21 because that would be.
Because it's money, so we want to be a little more accurate. Okay, last step, what do I do? Times 250 times 1.217. Okay, so if you leave your money in the bank account for 5 years, you don't touch it, you don't add money, you don't take out money, by the end of that time, you have $304.25.
That's a long time to leave
It
money.
adds to how much money?
Yeah, I just lost
Okay, so how much interest did the bank give you? Okay, guys, how could you figure that out? Okay, hold on, Spencer, I can't hear you. Okay, so I'm asking you guys how much money the bank gave you in interest. How would you figure that out? Yeah. Take how much money you have now, take how much money you started with. So the bank paid you $54.25 in interest. Okay. Any question on that? Okay. How many people think these word problems are easier than the ones we did before? Okay, a lot easier. All you got to identify is A, R, and T. Plug it in. You're done. I told you these word problems would be easier. Okay, so your homework tonight is going to be a worksheet on this section.